probably a lot or most of you are familiar with the CNDA and maybe some with MIRRIR, and then some of the other portals. So XNAT has been around, Dan, I'm sure recognizes the graphic from, but XNAT has been around for about 20 years now, starting from the CNDA, and it does a lot of cool things around managing imaging data, you know, just from sucking in the DICOM and populating a searchable metadata database to, you know, from the DICOM, organizing it into project subjects and experiments, access control, and then integrated pipeline processing, Jupyter notebooks, and the fact that it's customizable on the coming from the Human Connectome project, you know, we've done just a ton of customization and plugins on the XNAT system, and so you can really almost hang anything off it you want, but yet have it integrated in to the system. Really nice system. So out of the box, you get integration with the OHIF image viewer. It's fully scriptable, which we use all the time on the Connectome project. A REST-based interface, so you can write scripts to operate, you know, just across huge amounts of data. Organization by experiment is kind of, as sessions come in, they're pulled into experiments, but then, you know, often those are going to often in that, you know, within the DICOM, there's a subject in there. So it then organizes it under subject, and in that kind of all the data gets organized under projects, which is how people get their data, you know, is as a project of all their sessions and associated data. So like I said, the CNDA is kind of the original XNAT. It's been going for 20 years and about 20 years. Yeah, so over 175,000 sessions and now over 2,000 projects in that system. And it does get data feeds off the scanners. And then those are kind of set up as people add a new protocol to the scanner. And Jenny can correct me, I may not be totally correct on this, but as people get set up at the scanner, set up their protocol on the scanners, they get a project assigned, and then the staff gets added to the project in the CNDA. And so basically anything that comes off the research scanners automatically goes into the CNDA and becomes available to your project. And then CNDA can also reach out to the PACs, and you can pull in clinical data into your project as well that can supplement data that's collected under your project. So, and then CNDA itself implements container services, so it can do Docker-based container processing, which is fully automatable through the XNAT event service. So the CNDA operates a help desk that is there to help with pretty much everything: onboarding and setup, training, issues and questions. Data transfers is a big one, and image anonymization. So there's help out there to get started and get using the CNDA. Where we're headed with the CNDA kind of near term is what we're calling internally CNDA 2.0, but it is really going to be the CNDA. And it's the same CNDA. There's been a little, I think, worry that the CNDA is going away or something as it moves into the facility, but it's not. It's going to remain kind of an XNAT current version. The new version is going to be based on Ceph, which should make it more stable as we move off of ZFS, and we'll have Whistle key integration, better performance, because what we are doing with this, and really the main change with the CNDA 2.0 is it's now got 20 years of data and 20 years of projects on it, much of which is is no longer access. And so a lot of what we're doing really to improve performance substantially is to take all of the stuff that's really old, but that actually is getting drug around in queries and slowing down the system, and kind of leaving it in the current CNDA, which will become a CNDA archive. And so the data is going to be available. Dan might say maybe not forever, ever, but the data is going to be available for as long as we know, and in an archive format, and as in a read-only form. So now we'll talk a little bit about MIRRIR, and MIRRIR is more for, it was developed in-house, and you know, Dan's idea was, you know, I'm speaking for you, but the hospitals are collecting all this clinical data, and it would be really useful to researchers. And so the idea was to make a system that would be able to go out to the PACS, organize that data, pull it into projects, and make it available in an anonymized way. And so it's basically doing that. It's basically going out nightly and querying the PACS to see what's there, pulling that in as something available into MIRRIR, and so then we can do requests. So researchers can put in a request for data, and we do the data pull, and we get an anonymized data set. It can be supplemented with radiology reports and clinical observations, and then it gets delivered in a project in MIRRIR. Or we're kind of promising to be available on the CHPC on the file system. How to request data, it's a steps. You do need IRB approval for, to get at the clinical data. So basically the start is to contact MIRRIR Help and tell them what you want to do. And they'll work with you on that. So where we're going with MIRRIR is we're converting that over from its current kind of vanilla XNAT with operated by scripts, kind of almost externally to the system in a large way, to a flywheel discovery instance that really it's where, MIRRIR was kind of the original MIRRIR, but it really was more of a beta instance as it was here at WashU. As it has moved to flywheel, it's become a much more mature product and a lot slicker. It's an XNAT backend, and but it's got improved tools for discovery, active indexing into DICOM, going much deeper so that we can quickly search much more deeply into the DICOM to identify samples, and search and analytics dashboards to make identifying samples easier. And then the data pull process, which is now just kind of a bunch of scripts that we actually have to go, one of them runs on this machine, another runs on that machine, another runs on that machine. And it's still a bit of a manual process to get to do the script runs to do a data pull. This, the new system basically brings all that together. And so we can improve turnaround, I think, on requests for data, where sometimes now it takes weeks really to get data pulled. Yeah, I put this slide in there twice, it looks like. So Jenny was nice enough to put in this slide that just kind of identifies, because CNDA and MIRRIR both, you can pull in clinical data to both systems. She put this slide together to just kind of say, sometimes it's a gray area. Do I want my data to go into the CNDA or MIRRIR? But there's differences, and on the next page we'll see cost. I mean, there's cost differences, but the CNDA is really more, it's available not just under VPN. You don't just need VPN access. So if data needs to be available for multiple sites or something, CNDA is important, but CNDA is more meant to supplement data that's collected here with clinical data in general. Whereas MIRRIR is really for kind of large amounts of clinical data to do a clinical study. And I guess, you know, if the need is for both, there might be cases where your locally collected data stays in CNDA and do a big data pull in MIRRIR, but the MIRRIR CNDA staff can help with determining where data should go. This just kind of shows the fees for CNDA. Because of the department funding and the research, the department funding for just housing everything that comes off of research scanners, fees are around kind of the setup and management of multi-site projects and getting data that's external to the CNDA. So pulling data from the PAC or from the research scanner. So pulling data from the PACs, or if in a multi-site study, you'll get sessions that are pulled in from other data centers. There's charges per session charges for that. MIRRIR is more like it's envisioned more for big clinical data pulls. And so the per session fee isn't as much, but there's, you know, larger upfront costs just to get, you know, samples identified and data pulling in. We run a number of other XNAT instances, and the RCIF can do that, which is basically, especially for very large projects. And because XNAT is so customizable, it makes sense for some of the larger projects to basically have their own XNAT. So you're not paying fees for every data set that you're bringing in, and so you're not paying fees for every data set coming in, and it's just a branded instance. XNAT supports containerized workflows. Currently this is support for currently it's Docker support, and most of the XNAT instances we run have Docker swarms attached, and containers under container services can be configured for either manual launch or can be configured to auto launch via event services. CNDA as well as MIRRIR have a number of containers that have already been pulled in for other projects like DICOM to NIFTYs, they're free servers. So those can be, added to projects pretty easily. The next screens just kind of show the process of doing a manual launch of the containers. Nothing that useful there. This more shows up the setup for auto launching, where you can lock into specific events so that as sessions come in, if you want DICOM to NIFTY to run, if you want a face masking pipeline to run, something like that, you can configure that so as sessions come in, containers run automatically. Nice thing about container services, which is big improvement over the old pipeline engine, is just kind of the logging that's done. I especially like, so there's a lot of information about how the process was run. I especially like that you do end up getting just the standard error and standard output from the run. So you get the information is more available in XNAT to what happened in your pipeline than we used to have. So container processing is the container services plugin. Where we're going is so currently everything is running, and it runs on a Docker swarm, basically that's attached to each XNAT. And where we have issues with pipelines not running and stuff, it tends to be keeping these swarms running. Where work is happening now on a few fronts really is we want to get this container processing linked to the CHPC to where, potentially you can run either place, but ideally, because we have so much compute power on the CHPC, ideally, containers will just run out there and the Docker swarms will kind of go away. That's going to kind of require conversion to Singularity and then communication with the Slurm platform on the CHPC